Good morning, class. We are looking at statistics practice test number 3, module 3, covering chapter 6 and 7. Chapter 6, normal probability distribution. Chapter 7, estimating parameters and determining sample sizes. Here's chapter 6, normal probability distributions. So we're going to cover chapter 6. Answer the following. Part A, what percent of normally distributed data value lie within 2 standard deviations to either side of the mean? The answer is about 95%. The question is, why is that? Let's discuss normal distribution. Normal distribution is a curve which is bell-shaped and it's symmetric with respect to the mean. If it's a population, we call it mu. If it's a sample, we call it X bar. Now, the formula for this curve is very complicated. Y equals e to the power of negative, parentheses x minus mu quantity squared over 2 sigma squared, the entire thing over sigma over square root of 2 pi, or in this format, where e is the base of a natural log 2.718, pi is 3.14159, and it continues indefinitely. Mu is the population mean, sigma is the population standard deviation. And because it's complicated, what they did, they made up tables known as the Z table, okay, for this function. And of course, now you can use technologies such as calculators and TI calculators and so on. So what else do we know about this curve, which is called normal probability distribution curve? The normal distribution, and for short ND, curve is bell-shaped. The mean, median, and mode are equal and located at the center. ND curve is unimodal. It has only one mode. The curve is symmetrical about the mean. The curve is continuous. That means there are no gaps or holes. The curve never touches the x-axis. It goes to infinity along the horizontal axis and negative infinity. The total area, which represents the total probability under the curve, equals 1 or 100%, which means each side must have an area of 0.5. So these are some of the properties that we should know. We've already discussed this empirical rule. Remember, from the mean, you go 1 standard deviation away, or 2 or 3. What happens? The area under the normal curve that lies within the empirical rule, they all mean the same thing. Standard deviation of the mean is approximately 1 standard deviation of the mean within 1 standard deviation is about 68%. Within 2 standard deviations, about 95%. And within 3 standard deviations is about almost 100%, 99.7%. So this one within 2 standard deviation is about 95%. But why is that? If you go to the table, so from here to here, so this would be the region. You are going to write probability of z between -2 and 2. That means probability of 2 minus probability of -2. From the table, you pick those 2 pairs. I'll quickly show you in a moment. And the answer is 95.44%, and we say roughly 95%. In other words, we are discussing the table, the normal distribution, and how it works. For a continuous random variable, the probability of a single value of x is always 0. Why is that? A single value does not cover any area under the curve. So any Continuous random variable, a single value represents the area which covers nothing. It's 0. The probability becomes 0. The parameters of normal distributions are the mean is mu and the standard deviation sigma. We're talking about population. What are the values of the mean and standard deviation for SND, standard normal distribution? Mu is 0, sigma is 1. In the case of a standard normal distribution, mu is 0, sigma is 1. We should know that. Now, here's the table. You can find it online. You can find it in Canvas module, the last module, which is a bunch of resources, including formula sheets, tables, and so forth. So negative z-scores, positive z-scores, and what happens in the past, they just had 1. And the fact that it's symmetric with respect to the mean will help us figure things out. And remember, this is standard normal distribution. That's why mu is 0. That's why when we look at the score of a student, when the z is 0, that means it's equal to the average. If it's negative, below the average. If it's positive, above the average. Now, a couple of numbers that are important right here. If you look at this, is between 0.0505 and 0.0495. Inside represents the area. So this area of 0.5, and it corresponds to, if you were to read that, you would read negative 1.6 here, 0.4. So between negative 1.64 and negative 1.65, and they use negative 1.645. Another number would be here, 0.005. We have 2 zeros and then 5 between these two values. So again, if I were to read that, negative 2.57, negative 2.58 in between, negative 2.575. Now, on the positive z-score also, we have those. So this is just being able to read the table one more time. The z-score is the left number, and the top row will be the second decimal. For example, this number is 1.40, but this one is 1.41, the z-score of 1.41. That means if the area, if the z is less than 1.41, it covers this area 0.9207. It's perhaps too small to see it, but you get the picture. The idea is how to read the tables. Now, again, you can use technology ultimately, but that's what we are. Let's look at a couple of examples to make some sense out of this. So we want to find the value of a z for a standard normal distribution such that the area in the left tail is a 0.05. It's very important when we want to do that, we always do the drawing. So here's the drawing. It doesn't have to be to scale. We want this area to be 0.05, so we want to read this z-score. So right away, you should recognize that it has to be negative. For the sake of argument, it's a multiple choice. All of them are positive, and this, the only negative number is the answer, just to give you an idea. Okay, so how do we go by that? If you look at the table, and I don't have room for the entire table, that's why I got a portion of it. So the numbers are large enough for you to see. We are looking for the area of 0.05 inside. Remember, the z-score is the left number, which has 1 decimal, and then this is the second decimal. So if we continue, we notice, again, look at these two numbers. We don't have 0.05. 0.05 is between these two. So this one corresponds to negative 1.64, and this one negative 1.65. And so because we want 0.05, it's in between, so we can say negative 1.6 between these two, we would say 4.5. That's how you do the reading. Again, this has been calculated, believe it or not, using calculus. However, if you want to use the technology, is absolutely fine. For example, TI calculator, you use normal distribution, find the z-score. Second variables, inverse norm, 3 entries. Left area, value of the mean, standard deviation. So inverse norm, area to the left is 0.05, mu 0, sigma equals 1, paste it. And this number obviously has a lot more decimal than this. Okay, but if you were to stop here, then you have to change it because of 8 to 5. Again, you can find this in module 0 of MOM. You can find it in the syllabus. This is one of the calculators that works fine. Again, if you don't have a TI calculator, you can use a free calculator. Excel, it uses the following command, okay? Normal distribution, find the z-score, normal inverse, 3 entries, left area, value of the mean and standard deviation, enter. In other words, you can try with various technologies. Any technology is fine with me. Find the value of the z for a standard normal distribution such that the area in the right is 0.1. Again, always go with the drawing. The area to the right is 0.1. And the table gives you area to the left. If the area to the right is 0.1, the area to the left must be 1 minus that by the fact that the total area is 1. So this area is 0.9. So inside, for example, this is 0.6554, this is 0.7357, and 0.8051. You're looking inside for number 0.9. So the area is 0.9. 0.9 doesn't exist, but it's between these two numbers. So if you were to do the reading, 1.2 for this one, 8 for this one, 9. So it's between 1.28 and 1.29. Again, I want to make sure you can read the table. And normally we go in between, okay? But, you know, you may recognize that it's closer to that, just for the sake of it. Now, if you use the TI, you would say inverse norm, area to the left. So be careful to answer this. Area to the left is 0.9, mu 0, sigma is 1. So that's what you put in. And you enter that, you get the number that you are looking for. So you are using the calculator. This is the second. Vars, meaning variables. You read this and you bring this down to inverse norm and you enter. You want the area 0.9 or 0.9. It chooses mu being 0 and sigma being 1 because we're dealing with the SND, standard normal distribution, and paste, enter. It shows what we have there. And the answer, as you can see, is what was shown on the page. So I just wanted you to see how the calculator is used as well. So we did that, and the calculator gave us the answer we were looking for. Again, it's important to do this part by hand. Show your reader what steps you are using, and then eventually the calculator will do the job, and that's fine. Finding the following, find the probability of a z larger than negative 0.82. Always go with the drawing. Again, this doesn't have to be to scale. You have to recognize a negative number is on the left side of 0, of course. So you want the probability, that means you want this area. So you're looking for this number and you don't find it, you have to go with the table. I didn't have room. I put a portion of it. Negative 0.8 here, 0 to here. That means negative 0.82. What area would that cover? 0.2061. And so that is this area to the left. So what is the area that we want? 1 minus that. 1 minus that. Okay. And by the way, by symmetry, area to the left of negative 0.82 and area to the right of 0.82, of the less than 0.82. Okay. So area to the right of 0.82 and area to the left of negative 0.82 are the same. Area to the left of 0.82 and to the right of negative 0.82, these two areas are the same too. So it's just by symmetry, we should be able to recognize that. So if you go with the positive value, you should be able to read that one as well. So you can go to the positive and read that. In any event, various ways of reading the table. All right, so to a calculator, normal distribution area. If you want the area, you go again with second variables, and now you go with normal CDF. You need to put 4 entries. The left bound, the right bound, okay, and the mean and standard deviation. Now, here's what happens. It's important to know if you are looking at the left bound, in this case, if you're looking at the green one, this is negative infinity. But the way the normal distribution works, if you recall, when we looked at this concept in the beginning, we mentioned that according to this rule or the empirical rule, when we go 3 standard deviations on each side, it covers almost everything, 99.7%. So beyond -3 doesn't cover much, beyond +3 doesn't cover much. So for the left bound, if it's from negative infinity, you can put like -1000 or -100. For the right side infinity, you can put 100 or 1000, just to give you an idea. In any event, so lower bound is negative 0.82, upper bound is infinity. But you put a large number, even if you, and I highly recommend you try it, even if you put 10, probably works. But I put 1000 to be on the safe side. Mu is 0, sigma is 1. And that's the answer, which is, of course, with a lot more decimal than what we have in the table. But notice if you want to stop here, 8 changes to 9 because the number next to it is 9. So it's pretty close. The z value for mu for any normal distribution is always 0. Why is that? The formula indicates z is x minus mu over sigma. So if the x value is mu, we get 0. Again, the meaning is the z-score of 0 means the value is identical to the average, okay, for the data. That's the meaning of it. Usually, the normal distribution is used as an approximation to binomial distribution when NP, n times P, and n times Q are large. How large? In some texts, they go with number 5. In some texts, for example, in MOM, they go with 10. NP and NQ larger than or equal to 10. Find the area of the shaded region. In this case, the region is Z equals negative 0.93 and large. And the graph depicts the standard normal distribution of bone density score with mean of 0 and standard deviation of 1. So mu is 0, sigma equals 1. So simply Z, we want the probability of Z larger than negative 0.93. Again, by now we know how to use the table. It's very straightforward. However, we write this and then we can go to using any type of a technology. For example, a TI, normal CDF. Remember, you have to have the proper entries. And it gives you that number and you put it with how many decimals. Normally, they indicate how many. If they don't, you put as I would put all of it. If they don't indicate the number of decimals, I would put all of them. But in any event, if you give with 4, you go with 4, the next number is 1, so you keep it at 8. The graph depicts IQ scores of adults. And those scores are normally distributed with a mean of 100 and a standard deviation of 15. So what is given? Mu is 100, sigma is 15. It's very important to realize every question in statistics, almost every question is a word problem. So you have to translate it. So when you read that, you have to translate it symbolic. Okay. And so we are interested in this, finding the probability between 106 and 132. Now, the methodology of showing work is to go from the normal distribution to standard normal distribution. That means change the x to z using z equals x minus mu over sigma. So use mu and sigma are fixed. X, use those two numbers. So for example, I put 106, I get 0.4. I put 132, I get 2.133. And so this is normal distribution. Now we want the z to be between these two numbers. That's a standard normal distribution, everybody. That's standard normal distribution. So you want to be very careful with the way you approach this. And of course, at this point, what do you do? Well, you can use the table. Up to this number is this value 0.9834. Up to this number is 0.6554, and the difference between the two is what you get. If you go with the table, that's fine. You can go with, after this, you can go with technology and do it. Either way is fine, but understand the concept. At the very least, you must write this. And even if you use the technology and you use mu and sigma as 115, that works here too. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. Find the probability that a given score is between negative 2.13 and 3.77 and draw a sketch of the region. You should always do that. It helps with understanding the concept. So first of all, what is given? Mu is 0 and sigma is 1. That's important to understand. And again, this may not be to scale, but it will help you get the answer. So we want to go from this number, which is negative 2.13, to this number, which is 3.77, and somewhere in between is uh, the mean of 0. So we want the probability between these two numbers, and because mu is 0, sigma is 1, it's a standard normal distribution, we use z. It's important to understand why we use z, because mu is 0, sigma is 1. Now, you may use a calculator. Now, what is the lower value of this number? What is the upper value of this number? Mu is 0, sigma is 1. And it will give you the number here. And if we stop with the fourth one, we get 0.9833. Again, as far as the number of decimals, you want to always put as many as possible, okay? I'm just putting 4 here. For the exam, you want to make sure you put more or just whatever they ask you to do. Draw a graph and find P19, the 19th percentile. This is the bone density score separating the bottom 19% from the top 81%. So that means area to the left is 0.19, area to the right is 1 minus that, which is 0.81 or 81%. So 19% at the bottom, 81% at the top. Okay. So basically, if you use the table, inside the table gives you the area. You want to look for the area of 0.19. Now, it happened not to have it. So area to the left of 0.1922 has this z-score of negative 0.87. This is from the table. So 0.19 is there, is not there. Area to the left of 0.1894 gives you the z-score of negative 0.88. The point being, you may not find the value that you're looking for, but for sure it's in between. Look at this 0.19 is between these two numbers. Therefore, the answer for the z must be between these two numbers. So from the z table, you either use this one, this is closer, or you go in between everybody. Okay. I hope everybody's okay with that. So you go in between. So it's important to see how we arrive at the answer. So table has its limitation, and we are going to pay attention to that limitation. Okay. Now, of course, if I go with the technology, I can get a fast and easier answer. So let's go with the technology, which means inverse norm area is 0.19, mu is 0, sigma is 1, and that gives us this value. Now take a look at this value versus what we have here. Negative 0.877896, of course, a lot more decimals. If you were to stop at 3, then you would change this to 8 minus 0.87. This would go to 8. Again, however many decimals they ask us, we want to pay attention to the number of decimals that they ask. Okay, everybody, as always. using Excel. This is how you use. Just again, remember for negative infinity, you can use negative 1000. For infinity, you can use positive 1000. And this is normal distribution, normal CDF. CDF, cumulative distribution. All right. 3 out of 8 drinkers acquire the habit by age 20. If 300 drinkers are randomly selected using normal approximation to the binomial distribution, find the probability that exactly 100 acquire the habit by age 20. And I want to emphasize the concept that because of the fact that there wasn't really much of technology, they had to use approximation using normal distribution because using binomial distribution would be very difficult. Now, of course, technology has made it possible not to worry about that. So what are we dealing with? As we read this question, obviously they say use normal approximation to binomial distribution. This is a binomial distribution. So the moment you claim it's a binomial distribution, okay, you have to know what's N, 300, and what is P, probability of success. Remember, probability of success doesn't mean necessarily not something good, okay? So 3 out of 8, so 3 over 8. So you have a binomial distribution, short BD, N 300, and 3 out of 8, 3 over 8 is the probability of acquiring the habit. Age 20 is a piece of information that doesn't enter the calculation. So reminding you that in the case of a binomial distribution, P of x is n factorial over x factorial times n minus x factorial. This is Cnx, p to the power of x, q to the power of n minus x. Mu is np sigma squared of npq, and q, as always, is 1 minus p. So if p is 3 over 8, then q must be 1 minus that, which makes it 5/8, or this is 0.375, this is 0.625. Now, I stick with the exact answer because the denominator has 8, which is 2 cubed. If the denominator involves factors of 2 and 5 only, then you can get an exact answer. Otherwise, it continues indefinitely and you have to do the rounding. So in this case, makes no difference. Now, notice NP and NQ are large. If you multiply N, which is 300, by P, and by Q, you get large numbers. As long as they are large, we can use the normal approximation. And that's the key, everybody, okay? Because it's large, we can use a normal approximation. Otherwise, we can't, okay? Again, how large, remember, as long as it's larger than 5, you can, and in some texts 10, including in mob. So what are we looking for? Probability of x equals 100. Now, in normal distribution, remember, this is a binomial distribution. You can put it into this formula and come up with the answer. It's really not a big deal, okay? Because we have the P, we have the Q and everything. You can also use the technology. But as far as approximation is concerned, when you looking at binomial distribution is discrete, normal distribution is continuous, and a single value, in this case, a single value, has a probability of 0 when it comes to continuous random variable, including the normal distribution, because it doesn't cover any area. Therefore, they make up an area by looking at this number and go a little bit to the left, a little bit to the right, and statisticians have decided that is 0.5. So they're going to put 100 between 99.5 and 100.5. So they use 0.5. It's called continually correction factor, because you're going from a binomial, which is discrete, to normal, which is continuous. So this is normal distribution. Now we are going to go to SND, standard normal distribution. We're going to go to Z, and Z is X minus mu over sigma. So let's calculate mu and sigma, where mu is NP and sigma is square root of NPQ. Mu is 112.5, sigma is square root of NPQ with a bunch of decimals. And again, the reason we do that, because Z is X minus mu over sigma. 99.5 becomes negative 1.5503, the Z score. 100.5 becomes a Z score of negative 1.4311. And that means normal, so this is binomial distribution. This is normal distribution. Now these two numbers is S and D, standard normal distribution. And that means this little area using the bell-shaped curve. So this is negative 1.5. This is negative 1.43 roughly. You use a table and you end up with 0.0158. Now, everything is done by hand here, and every step is shown. We are going to look at technology, and you may use technology as follows. But it's important to write the given PQ, okay, NPQ, NP and NQ are large, and you want this one. Now, normal approximation, you must write this one. Now, from here, if you want to use the technology, it's fine. Although it's really a good idea to go to the Z-score. You are showing all the steps in any normal CDF, the Z-scores that we have here. Of course, look at the Z-scores here. I have more decimals, okay? I put it here. And I get this number. If I go with binomial, I have to go binomial PDF. Why PDF? Because there is one value, okay? N is 300, P is 0.375, X is 100. Look at that number. Look at all those numbers. This is from the table. This is from normal CDF technology. This is binomial PDF technology. And look, they're all extremely close. Now, just to make a point, if you were to stop as right here as the fourth one, so 1, 2, 3, 4, 7 changes to 8. 1, 2, 3, 4, 7 changes to 8. So you see they become identical with 4 decimals. Of course, technology uses a better value. Binomial PDF is the right one. Normal CDF, see how close they are? Okay. That's why they used normal CDF instead of binomial, because binomial was very difficult. Now, for this one is not too bad, but if we continue with the next part, at least 125 acquired the habit by age 20. This is the part that using binomial is near impossible, because you have to, at least 125, you have to calculate from 0 to 125. So the formula that was used in the binomial distribution, you let X be 0, 1, 2, 3, all the way to 125 and add them up, at least 125, all the way to 125. So this is the information from the previous page. We have the N, we have the P, we have the Q, we have mu, we have sigma, and we want probability of X at least 125. That means greater than or equal to 125. Now, which means X is 125, 126, all the way to 300. So you have to calculate all of those values and add them up, which is very difficult. And so now here's the 0.5 continually correction factor, okay? We're going to use 124.5 and y 124.5, 125.5. When we are dealing with one value, as we did in the previous page, 100, we used 0.5, we subtracted and we added. But over here, what do we do? Subtract or add? Here's the important part. We either have to use this one or this one. Now the question is which one and what? Well, if you go with this one, everybody, the first discrete value larger than this would be probability of 126. Of course, it's not discrete and so on. But this one, the first one would be probability of 125, x equals 125, and so on. And look at this one here. We need 125. So if we use this one, we miss 125. That doesn't work. Okay. That's why you go with 124.5. It's important to understand whether we add or subtract which one and why. And so this is called continually correction factor. The continuity correction factor or continual correction factor is applied when a continuous probability distribution is used for approximating a discrete probability distribution. It acts like a bridge between the continuous normal distribution and discrete binomial. That's what it does. And again, just to make sure we understand what's going on here, especially if you go to the previous part, part A, the probability of a single value is 0 when it comes to normal distribution. All right, so now what do we do? Now we're going to go to Z equals x minus mu over sigma. We have the mu, we have the sigma, and now x is 124.5, results in 1.4311. Using the table. Again, area to the right of. It's really important to do the drawing, so it gives you an idea. It should be pretty small. So remember, the table gives you all the way to this number. So this area to the left of this number is 0.9236. You subtract from 1, and you get what you're looking. So the answer is 0.0764. I'm going to continue with the third part, the same question, part C. At most, 165 acquired the habit by age 20. Again, information from the previous page. So we want BD, binomial distribution probability of x less than or equal to 165. So that means we want the probability of x equals 165 plus 164, 163, all the way the probability of x equals 0. That's the meaning of it. So why is it important to write this? You want number 165. So you have two choices. Are we going to go with for the normal distribution? Probability of x less than 165.5 or probability of x less than 164.5, because you want a 0.5 continually correction factor. So either you have to add 0.5 or subtract 0.5. See, when it's a single value, you have to do both. When it's one of them, you have to do one of those. So which one and why? This will help you see that. If I go here, less than 164.5, and by the way, whether I put equality or not, it makes no difference. The reason it doesn't make any difference, For binomial distribution, it does make a difference. If you put less than, 165 is not there. But for continuous probability distribution, such as normal, makes no difference because one point has a probability of 0. So put the equality or not makes no difference. So less than 164.5, the first number would be 164. Less than 165.5, the first discrete number would be 165. Therefore, you have to go with this one. So you have to make a proper decision. So we go with this one. So BD, binomial distribution, has this format. ND, normal distribution, has this format, probability of X less than 165.5. And again, as I said, even if you put the equality, it makes no difference. So that's the normal distribution. Now, what about SND? Z equals X minus mu over sigma. Mu and sigma, we already have it. And now we use 165.5 as X. We get this number. And so we want the probability of Z less than 6.3206. To be honest with you, this really means, remember, if you start from the mean and go 3 standard deviations on both sides, it covers 99.7%. So the left side is covered, the right side up to 6, that means almost 100%. Now, from the table, okay, so we want almost everything. From the table, above 3.5 in the Z table, it gives you 0 point and it gives you 4 nines, which is, as you can see, almost 100%. That's from the table. You can use the technology, you see what it gives you, but if you go with a couple of decimals, it becomes 1 or 100%.